Hello, this is Matrices and Determinants, Solving Systems Using Inverse Matrices, Example 2. Example 2 says go ahead and solve the matrix equation that we set up in Example 1. So this is everything we did in Example 1, and what it boils down to is we have to figure out the inverse of matrix A. So this is matrix A, and we'll need its inverse. Now from before, if this is matrix A, the inverse is 1 over the determinant of A times this matrix, where the A and the D have switched places, C and B have kept their places but became negative. So we will figure out the determinant of matrix A. So we'll be doing the determinant of -3, 2, 4, -1. It's actually -3, 4, 2, -1. So this determinant, to figure out this determinant, it's AD, which is -3 times -1, which is +3, minus 2 times 4, which is 8. So this determinant is -5. So we figured out that this fraction, 1 over the determinant of A, is -1/5. Okay, so we're going to have the inverse of that is going to be -1/5 times, now this is our original matrix, and we need -3 and -1 to change their places. So the -1 goes up here and the -3 down here. The 2 and the 4 keep their positions, but their signs change. Okay, so I can do this scalar multiplication here, and this will be our inverse matrix. So this is +1/5, this is +2/5, this is +4/5, and this is +3/5. So this is equal to our inverse matrix. So according to our original equation, we have to take this matrix and multiply times B. So B is 5, -10. And we're multiplying, and we got to make sure we multiply from the left. That's a to the -1 times B. So 1/5, 2/5, 4/5, 3/5 times 5, -10. Okay, so we have a 2 by 2 matrix times a 1 by row and column. So it's 2 rows, 1 column. We have a 2 by 2 matrix times a 2 by 1 matrix. It is possible because those are equal, and the result is going to be a 2 by 1. So our result is going to have 2 rows and 1 column, and to get, so there's going to be one number here and one number here. To get this number up here, it's going to be this times this. So 1/5 times 5 is 1. 4/5 times negative 10, it's going to be 1 minus 8. And then to get this, it's going to be 2/5 times this. 2/5 times 5 is 2. And 3/5 times negative 10, it's negative 6. So this is equal to negative 7, and this is equal to negative 4. And from our original equation, now we have figured out this. So from our original equation, we have the variable matrix xy equal negative 7, negative 4. That means x is negative 7, y is negative 4.